graphs of equations. We're going to sketch graphs of equations. We're going to identify x and y intercepts of graphs of equations. We're going to use symmetry to sketch graphs of equations, and we're going to write equations of and sketch graphs of circles. The graph of an equation. Now, here's a little bit of review. The first one, these are linear functions. Why are they linear functions? Because the highest power is 1. So we know that these are going to be a linear function because this is x to the first and this is x to the first. These are in slope-intercept form, so my y-intercept is 4 and my slope is 2, so I go up 2 over 1, up 2 over 1, and I would just draw, oops, kind of missed some of my points there. I would draw my line in there. Okay, now, let's say we forgot that. Let's say, oh man, it's been a long summer. Last year we had COVID, so we didn't do a lot in math at the end. How can you always graph a function if you don't know what it looks like? Well, usually most students started off in like Algebra 1 using what we call a t-chart. And you come up with some values. You know, most times I always tell kids to go do 4 or 5 values. So, and I always start with some negative. So negative 1, 0, 1, 2. So if I put negative 1 in here, 2 times negative 1 is negative 2, plus 4 is positive 2. If I put 0 in here, 2 times 0 is 0, plus 4, that's 4. If I put 1 in there, that's going to be 6 and 8. So I could plot these points. So using a t-chart works with every type of function. It doesn't matter if it's linear, quadratic, absolute values. You can always use a t-chart and plot points. So negative 1, 2 is right here. 0, 4, which was my y-intercept. 1, 6. Now we can also talk about x and y intercepts here. This is what we call a y-intercept. A y-intercept always has a 0 for the x value. And the x-intercept now, I'm not sure, because I didn't graph really carefully, so I'm not really sure what that would be, but I know that my y or my x-intercept, the y value has to be 0. So if I put 0 in here and I solve this, so if I subtract off 4 there, that would give me negative 4 equals 2x, so x equals negative 2. So I know the y-intercept has to be right down here, so I kind of missed it a little bit with my graph. So those are x and y intercepts, and we're going to talk about those also today. And if it's graphed out, you can just see them. I mean, the y-intercept is where it crosses the y-axis. The x-intercept is where it crosses the x-axis. Now, in this problem here, I could make a table out, or I could just look at this and say, oh, the y-intercept is at 2. My slope is negative 1/2. So I go down 1 over 2, and then I just draw my line in. Now, I could also graph this by plotting points. That's a great way of graphing functions. Now, a lot of kids are going to say, oh, Mr. Shank, I've got a graphics calculator. I'm just going to graph everything. And that's perfectly fine. In this class, you can absolutely use a graphics calculator. I don't know how many of you use Desmos calculator. It's a free online calculator. It is probably one of the most amazing online calculators that they have out there. It does everything that we're going to be doing this year. So if you have never used it, please take a look at it, and we'll be talking a little bit more about it a little bit later on in this presentation. Now here I have, oh no, now my x term is squared, so I know these are going to be parabolas. So I know they're going to look something like this. Why do I know that? Because I'm in pre-college math and I've learned this stuff already in Algebra 2 and Algebra 1. All right, I'm just assuming that you guys know this, but that's okay. This is the parent function for a function. Now, a lot of students, when they were taught how to graph, now, absolutely, could I make a t-chart here? Yes, I could. But I remember this pattern for parabolas, 1, 3, 5, and I know the vertex here is 0, 0. Why do I know that? Is because this is the parent function. Then I go over 1, up 1. Then I go over 1, up 3, over 1, 1, 2, 3. Then I go over 1, up 5. 1, 2, 3, 4, 5. Why do I do that? Because I know this is a pattern. Now, I also know that a quadratic is symmetric with the y-axis, right? So I know that if I go over 1, up 1 here, over 1, up 3, over 1, up 5, my parabola will look something like this. And that's why this is a line of symmetry. And a line of symmetry, if we know a function is symmetric, then we know that it's going to be the same on the right-hand side and left-hand side. And that's what symmetry is all about. Now in this problem, this is written in vertex form, so let's see how much you guys remember. And you guys didn't have, well, some of you might have had me before, but I always draw this little V here. This points to the vertex. It's always opposite of what's inside. So -2, -3. That is my vertex. So I go over here, -2, -3. I put a point there. And that's my vertex. And then again, my pattern is 1, 3, 5. So I go over 1, up 1, over 1, up 3, 1, 2, 3, over 1, up 5, 1, 2, 3, 4, 5. And I do the same thing on this side since it's symmetric. 1, 2, 3, and 1, 2, 3, 4, 5. And there is, oh, I kind of missed a couple of my points again. There is my graph of my quadratic. Now, could I check myself? Absolutely. I'm going to write this equation down because I haven't told you guys how old I am yet. I'm old. This is my 35th year of teaching, so I've been doing this for quite some time. But I always check myself, okay? And I'm going to show you guys how to check yourself. I'm going to open up Desmos Calculator, and this is the calculator I was talking about that I think is amazing. And all you have to do is type in Desmos into your URL, and it'll come up. But I'm going to show you how to use it. Okay, so I need to, let's see here. I need to share an application, and I'm going to do a Chrome tab. I'm going to do my Desmos Calculator. Okay, so this is a Desmos calculator. I just typed in desmos.com. Really, I just typed in Desmos, but now if I want to put in an equation, what was my equation? Y is equal to x parentheses x plus 2 parentheses squared minus 3. And you can see, oh, Mr. Shanklin, you were pretty right on there. The vertex was at -2, and this point here, -2, 3, I can just point to it. It tells me exactly what value it is. I can find my x-intercepts just by putting my cursor on there, and you can see my x-intercepts are really nice numbers, decimals, and here's my y-intercept, 0, 1. Oh, so this Desmos calculator will graph out any type of function that you want. And the nice thing about Desmos calculator is in a lot of graphics calculator, TI-83, you have to have everything y is equal to. Well, we're going to be dealing with circles in a little bit, graphing circles, and I know that this is a function for a circle, x squared plus y squared is equal to 16. I know that's, I need an equal sign in there. I don't have an equal sign there. All right. Is equal to 16. I know that this is a circle. Its center at 0, 0. I know that the radius is 4. So look what, I didn't even have to have a y is equal to. Desmos understands. Here it is, center is 0, 0. Oops, I can't use my tool on here. But here, I know that the radius is 4 also. So Desmos is an amazing way to check your work. And this is an online course. You can absolutely use graphics calculator if you wanted to, and Desmos is a really good one to use. Okay, so now I have to get back to my presentation, so I have to go back to my slides. This is where it gets a little clumsy because it goes back to nothingness, and I have to get my slides out again. All right, so I have to slide down here. Okay, so now we're right here. It says, you have used a coordinate system to graphically represent the relationship between two quantities. Okay, we've done that. There, the graphical picture consists of a collection of points in a coordinate plane. Frequently, a relationship between two quantities is expressed as an equation in two variables. For instance, y is equal to 7 minus 3x is an equation in x and y. An ordered pair AB is a solution or solution point of an equation. Basically, what they're saying is we can graph these things just by finding points there on the line, just finding some x and y values. So for example, if I put 1 in here, for x, 7 minus 3 times 1, that's 4. So if my x value is 1, my y value would be 4. That is a point that is on the graph. So if I wanted to graph this out, I could make a table of values and graph this out. So the basic technique used for sketching the graph of an equation is the point plotting method. Okay, we used to call it making a t-chart and plotting the points, right? And that's why I said a lot of the stuff that you're going to see in pre-college, you've seen already. I mean, I hope by the time you get to pre-college that you have plotted points and graph lines already. I mean, that's one of the things that we spent a lot of time in Algebra 1. Algebra 2, we spend a lot of time, and I teach Algebra 1, I teach Algebra 2. So I know that we spend a lot of time. We don't spend a lot of time using t-charts. I mean, we kind of go past that and, you know, do like slope and norm. But if you are in any way that you don't understand how to do a problem, you make a t-chart out and you pick some values for x. Oops, my pencil's off now. You pick some values for x, you plug it into the equation, you get your value for y, and this is your ordered pair that you're going to graph out. Okay. Now, that's if you didn't know how to graph it normally. I mean, I'm looking at this graph. I was like, oh, okay, my y-intercept 7, 1, 2, 3, 4, 5, 6, 7. I put a point there. My slope is -3, so I go down 3/1. So my graph looks something like this. That's a really quick sketch. That is way quicker than having to come up with a point and a t-chart. So I'm hoping you don't have to use t-charts, but if you do, that's okay. I mean, it is the beginning of the year. We're just getting our feet wet with math. You do what you have to do in this class. All right. Now, there's a graph. Now, it's not, my graph wasn't as nice as this one, but, you know, quick sketch of a graph, you should be able to figure that out in your head. All right. Now, each week we have a practice assignment. It's a weekly practice, and the practice assignment each week has 10 problems, and they are all multiple choice. And you have to get an 80% on the practice in order for the assessment to be released. Anytime on a lesson tutorial, if you see a yellow background and a red practice, that means this problem is on the practice this week. So this is one of the 10 questions for this week. It says, determine which of the following point lies on the graph of the equation. So they're giving us an equation. Y is equal to the square root of x plus 25. All right, they're giving us that. And they're asking us, which one of these points lies on this graph? Well, you know, I know that this is it looks like this. I believe it starts at -25, if my math is correct here. So this is way back here at -25, and this graph goes like this. Okay, so which one of these points lies on this graph? Well, I could just plug it in here. So if I put 0 in here, 0 plus 25 is 25, the square root of 25 is 5. So my y value would be 5. That's not correct. Oh, this looks correct, right? Because if I put 0 in here, 0 plus 25 is 25, the square root of 25 is 5. This point should be on my graph. And this is just a real quick sketch, but 0, 5 does look like it could be on my graph. Okay. It's a fairly easy practice problem, right? I mean, it shouldn't be too hard. How about this one? It's a determine which of the following points lies on the graph of this equation. Well, I know that this is an absolute value function. I know that this is going to be a v, so I know my graph, let's see here, 6, 4, so over 6 up 4. So I know my graph is going to look something like this. Now, you know, if you don't know that, that's perfectly fine. You can use Desmos calculator to graph it in, but it's not asking us to graph. It's just asking us which one of these points lies on this line. So if I put 2 in here, 2 minus 6, well, that's -4 plus 4. Well, the absolute value of -4 is 4, so 4 plus 4 is 8. Huh. That kind of seems like it's on the graph. I'm gonna pick that problem, or that answer, 2, 8. Now, if I look over here, 2, 8, that does look like it might be the correct answer. But I didn't use graph paper, so not 100% sure. But just by plugging it in, sure looks like it's correct. Okay. Next thing we're going to deal with today is intercepts of a graph. It is often easy to determine the solution points that have 0 as either the x-coordinate or the y-coordinate. These points are called intercepts because they are the points at which the graph intersects or touches the x or y axis. So if it's graphed out for you, it's super easy to tell the x and y axis. This is the y-axis, the x-axis, so it crosses right here. So there's no x-intercepts, but I do have one y-intercept. Here I have 1, 2, 3 x-intercepts, but I also have a y-intercept because this point right here is an x and a y-intercept, right? Because it's on the x-axis and the y-axis. Here I have 2 y-intercepts, 1 x-intercept. Here I have no intercepts. So if I give you a graph and I ask you what the x and y-intercepts are, it should be fairly easy. Now, if I give you an equation and I ask you, I would expect you to go to Desmos calculator, plug it in, find the x and y-intercept. Pretty easy stuff, right? But that's just being able to tell what the x and y-intercept of a graph is. Some texts denote the x-intercept as the x-coordinate of the point A, 0, and the y-intercept as the y-coordinate of the point 0b. So x-intercepts, we know, in order to be an x-intercept, the y value has to be 0. Has to be. Because if you graph something out, let's say I graph this, oops, I'm talking about x-intercepts. This is the x-axis here. So this point here would be like -4, 0. The y-intercept has to be 0. If you're looking for an x-intercept, the y value has to be 0. And that is why we can find x and y-intercepts if we didn't graph it out. For example, if I said y is equal to 2x plus 3, and I asked you to find the x and y-intercept, okay? Well, it's pretty easy. If I want to find the x-intercept, I just put 0 in for y. If I want to find the y-intercept, I put 0 in for x. So let's find the y-intercept. It's much easier. So I put 0 in for x. So if I put 0 in here, y is equal to 3. That's my y-intercept. If I want to find the x-intercept, I put 0 in for y. So that would be 0 is equal to 2x plus 3. Subtract off the 3, so -3 is equal to 2x. X equals -3/2. So if they give you an equation and you're trying to find x-intercept, just put 0 in for y and solve for x. And if you're looking for a y-intercept, put 0 in for x and solve for y. It's super easy, okay? So that's finding x and y-intercepts. Identify the x and y-intercept of the graph. Y is equal to x to the third plus 1, shown below. Okay, well, it looks like the y-intercept is 1, and it looks like the x-intercept's -1. Well, I could check it out real quick. I've got y is equal to x to the third plus 1. If I put 0 in for x, y is equal to 1. So the y-intercept is 1. Checks out. And the x-intercept, if I put 0 here, 0 is equal to x to the third plus 1 minus 1. So -1 is equal to x to the third. If I take the third root of both sides, the third root of -1 is -1. So I could see the answer, but I also could do it algebraically. Okay? Either way is fine with me. Here's another problem offered your practice this week. It says graphically estimate the x and y intercept of the graph. Y is equal to 81 minus 9x squared. Okay. Graphically, well, it's not very big. And after I've been teaching 35 years, you know I've got to be pretty old. I can't really see the values there. Looks. Now, I might just go to my Desmos calculator and plug in 81 minus 9x squared. That way, I would have a much clearer picture of what that is. Okay, I know on your practice you can just hit Command plus and it'll make it larger. I don't think I can do that on here. I don't think I can make this larger. Well, looks a little bit larger, but then it jumps right back. So I better change this back. It's really small. Okay, so I'm not going to tell you what the answer. Oh, I suppose I could do it algebraically. Okay, so I can't see it. All right, so I am going to algebraically figure it out. So I'm going to put 0 in for x. So that gives me y is equal to 81. All right, so my y-intercept has to be 81. Okay, y-intercept has to be 0, 81. Now, if I'm going to do it, I'm going to put 0 in there. So 0 is equal to 81 minus 9x squared. I'm going to bring the 9x squared over here. Equals 81. Divide through by 9. X squared equals 9. Divide, take the square root of both sides. X equals plus or minus 3. So even though I'm old and I can't see much, I can still figure it out. The x-intercepts are going to be plus or minus 3. Okay, and my y-intercept is going to be 0, 81. So even though I could not see the problem, I can still answer it because I can just do the math. All right. Symmetry. Now, as I said in the beginning, a lot of this stuff you guys should know already, right? Graphing functions using points, t-tables, finding x and y intercepts. Symmetry, another one that you should know. Symmetry, graphs of equations can have symmetry with respect to one of the coordinate axes or with respect to the origin. Symmetry with respect to the x-axis means that when the Cartesian plane were folded along the x-axis, the portion of the graph above the x-axis would coincide with the portion below. So this one has, this is the line of symmetry, the x-axis. If you fold this down, it would be. So now what's the most important thing to know? That if you have an ordered pair x, y, that x negative y would be a value. So if I said that this point here was 1, 4, I know that 1, negative 4 would be a point on the graph also if it's symmetric about the x-axis. Okay? That is a very important point to know. All right? And then if it's symmetric with the y-axis, okay, the line of symmetry, then we know that it would be, so I gave you this point, if I knew that this point here was 2, 2, I know that point negative 2, 2 would be on the graph. If it was symmetrical, I just made up a word. If it was symmetric with the y-axis. If it's symmetric with the origin, that means if you drew a line, and this line is y is equal to x, that is the origin, okay, or you could this way also. So if we fold this down along here, it would be symmetric with the origin. And that is where you have x, y. So if I give you a point, let's say 2, 2, you know that negative 2, 2, negative 2, 2 would also be a point on the line of symmetry or on that graph if it's symmetric with the line of symmetry. And here are some good notes to have. Symmetric with the x-axis, symmetric with the y-axis, symmetric with the origin. You can conclude that the graph of y is equal to x squared minus 2 is symmetric with respect to the y-axis because the point 37 and the point negative 37, okay, are both on the graph. That means it is symmetric about the y-axis. So you should be able to look at that and say, oh, that's symmetric about the y-axis. Okay, and here's the tests, which are just basically the other what we had already. Circles. All right, two different types of circles that we're dealing with this week. This one, x squared plus y squared is equal to, let's say, 16. And then we could have x minus 1 squared plus y plus 2 squared is equal to 16. All right. The generic formula for a circle with the center 0, 0 is x squared plus y squared is equal to r squared. Okay. This one here, that looks exactly like this. So I know that the center here is 0, 0. And I know the radius is 16. No, the radius is not 16. The radius is 4 because r squared is in the formula. So r is the square root of this, so it'd be 4. So I know I go up 4. I'm sorry, I go to the right 4, up 4, to the left 4, down 4. And then if I do a really nice job of drawing, that is the circle for that equation. Now, here, the generic form is x minus, I think they use h squared plus y minus k squared is equal to r squared. This is the center. But remember, it's opposite, okay? So if this is my center here, so that's going to be positive 1, negative 2. So the center of this function would be positive 1, negative 2, and the radius would be 4. So I go to positive 1, negative 2. My radius is 4, so I go 1, 2, 3, 4. 1, 2, 4, and 1, 2, 3, 4, and 1, 2, 3, 4, and I would draw my circle. All right. Now, Mr. Shingle, I don't agree with you. I don't think the center is 1, negative 2. Okay. People don't agree with me a lot of times. Okay, that's just the way it is when you're a teacher. Sometimes they just don't. So how can I prove this? How can I show that this is really the center and the radius and all that kind of stuff? I would go to Desmos calculator. So let's try that again with this equation. So I'm going to share an application, a tab. I'm going to go to Desmos. Okay. So now I'm going to get rid of these equations that we had before. And I'm just going to type this one in. I believe it was x minus 1 squared plus y plus 2 squared is equal to 16. There's my circle. Where's the center? What did we say it was? We said it was 1, negative 2. So let's go over to 1, negative 2. Is that my center? Sure looks like it. Okay, so we can always check our answers on Desmos calculator. All right, again, now I have to stop sharing and then I have to go back to my presentation. This is where it gets a little wonky when you're trying to do slide presentation. You always have to go back. All right, so where were we? We were way down here. We just graphed some circles. Okay, so we just graphed some circles. So now it says consider the circle shown at a point xy is on the circle if and only if the distance from the center hk is r. The distance formula. So now they're getting into some interesting problems. If they gave you a point on the circle, let's say that this point, I got to turn my pen back on. Let's say that this point on this circle is, let's say it's 6, 3. And we know that the center was 4, 4. And we didn't know what the radius was. Well, we can use this amazing formula. X squared minus h squared. This is a distance formula. So I could go, well, my x value is 4 and the distance formula. So we can find the radius. So so I could go 4 minus 6 squared plus 4 minus 3 squared. Now, guess why you square it? Because it takes away the negative. So 4 minus 6 is 2, negative 2, that's 4, plus 4 minus 3 is 1. 1 squared is 1. So this is going to be the square root of 5. So my radius is going to be the square root of 5, which is okay. Because now when I write my equation for this thing, so it was 4, 4, so this would be x minus 4 plus y minus, I gotta go squared, plus y minus 4 squared is equal to 5. Why 5? Well, my radius was the square root of 5, so I have to square that, right? Because the formula for a circle is x squared plus y squared is equal to r squared, so I have to square it. Pretty amazing. Not very difficult, but puts a lot of stuff together. All right, and here's the formula for a circle. This is one that the center is not 0, 0. This one is the one with the center is 0, 0. So in this problem, it says the point 34 lies on a circle whose center is negative 1, 2. Write the standard form of the equation. Well, I know it's going to be x plus 1 squared plus y minus 2 squared is equal to r squared. Why do I know the 1 and the 2? Because they gave it to me here. This is, oh, yeah, that is the center. They told us that that is center. So now I still need to know what the radius is, okay? So the radius is just going to be, I just have to use the distance formula again, right? So negative 1 minus 3 plus 2 minus 4 squared, and that gives me 4 squared plus 2 minus 4, that's negative 2 squared, which is 4. Oh no, oh, that's squared, so that's 16 plus 2 minus 4, that's 4, so that looks like 20, the square root of 20, looks like. So then r squared is going to be 20 here. Okay, hope I did that correctly. Now, if you don't want to use the distance formula, guess what? We, or you, should have taken geometry. And geometry says that if you have, you can use Pythagorean theorem. I know the distance from here to here, it goes from negative 1 to 3, right? That's my x values. So this is 4. And then I go from 2 to 4. So this is 2 here. A squared plus b squared equals c squared. So 4 squared plus 2 squared is equal to c squared. So 16 plus 4 is equal to c squared. Oh my goodness, I'm going to get the same answer. So I just used Pythagorean theorem. A squared plus b squared equals c squared. Boy, Mr. Shanklin, you're so smart. Well, thank you. All right, and the last slide for today. It says, write the standard form of the equation of a circle with the given characteristics. Center 4, 5, and radius 3. Okay, so I've got x minus 4 squared plus y minus 5 squared is equal to 9. Done. Let's see here. That looks like letter A right off the bat. I hope. Yep, sure looks like that. All right.